Whether or not mankind's written history is a simple blip of 10 or 5 seconds in the terrific plan of the universe, one thing is clear: the universe is a motherlode of old miracles. Furthermore, interminable motivation moves our look to our infinite terrace. The smooth way has an enrapturing astronomical tango at play. Later estimations hint that stars on the edges of our universe are swaggering their stuff in sluggish movement, contrasted with their partners in other universes. What's the inestimable scoop? Well, there are several hypotheses, and one murmurs that our smooth way may be low on an imperceptible enormous fixing called dark matter. This tricky substance impacts the gravitational dance of heavenly items. There's a grandiose puzzle involving dark matter, the baffling substance we can't see but that appears to play a gravitational pull of battle in the universe. One chance shaking our astronomical comprehension is that perhaps we've been seeing dark matter the wrong way. Our vast compass may be pointing off course. Here's where the European Space Agency's Gaia satellite strides into the inestimable spotlight. It's like our inestimable investigator giving complex insights about the dance of almost 2 billion stars in our smooth way. Consider it a cosmic movement sample. The satellite's exact estimations have driven space experts to re-examine their grandiose movement notes. Stars at the external edges of our smooth way appear to be taking it slow, testing our old suspicions about their speeds. Now, how do star speeds spill the infinite beans about a cosmic system's weight? It's like checking the size of a group by how quick individuals are moving. Space experts, furnished with Gaia's data, assess the combined load of our universe's gas, dust, stars, and that tricky dark matter to be around 200 billion times our Sun. It seems like an inestimable heavyweight, but here is the unexpected development: it's around 5 times short of what we figured. One hypothesis to unwind this grandiose question suggests we could have been a bit blundering with our dark matter estimates. Perhaps there's less dark matter out there than we previously accepted. It's like figuring out there are fewer ingredients in your soup than you naturally thought. But hang on, gauging a system is like trying to do something that's simply impossible. Famously precarious, the data could have a couple of characteristics, or our enormous estimating tape could require some changes. Still, different research groups have joined the celestial examination, and they all seem to be murmuring the same grand tune. If this infinite disclosure holds, it's like opening another chapter in our vast physics course reading, an upheaval that could make us reconsider not just our own smooth way, but every ritzy corner of the universe. As Stacy McCord, a space expert at Case Western Reserve University, puts it, this could be an infinite game. Take an astronomical journey back to the 1970s when space expert Vera Rubin and her vast group set out on a heavenly adventure. Their mission, concentrating on how stars partition in other worlds. Now, the infinite playbook proposed that stars on the edges of a world ought to be enormous dawdlers, contrasted with the zippy stars close to the center. Here's where the unexpected developments occurred. Rubin and her stargazing crew uncovered a huge shock. Stars at the most distant scopes of worlds were swaggering their stuff at almost similar speeds as the ones closer to the vast dance floor. Imagine a cosmic disco where everybody, regardless of where they are, is moving to the same beat. This infinite disclosure alluded to the presence of something puzzling and hidden: dark matter, the imperceptible heavyweight champion that shapes these gigantic radiances around systems. Now, focusing in on our grandiose lawn, the smooth way. Imagine trying to watch everything in your room while being inside it. Interesting, right? Cosmologists faced a similar vast challenge, expecting that the smooth way stars played by the same standards as those in other cosmic systems. For example, our Sun, dwelling around 26,000 light-years from the cosmic heart, marvels at 800,000 kilometers per hour. The Gaia satellite, sent off in 2013, resembles our accuracy grandiose ruler, measuring the positions and cool moves of smooth way stars in 3 aspects. The data it's been sending back resembles a grandiose orchestra steadily refining its accuracy over time. The hypothetical physicist Francesco Cini and his enormous investigators from the Enrico Fermi Study and Research Center in Italy seen unobtrusive traces of a heavenly lull a couple of years ago, and with Gaia's most recent data drop in 2022, these hints became vast fireworks. the new data is twice as definite as the information from 2018. Space experts now employ moved-along devices to follow star parts with laser accuracy, arriving at astronomical distances that were once a bit fluffy in the heavenly theater. In 2023, four isolated research papers have divulged a heavenly shock. Stars up to an incredible 100,000 light-years from the smooth way's heart appear to be moving slowly. It's like the stars are raising a ruckus around the town in a clarion decay, reminiscent of the planetary artful dance Johannes Kepler described hundreds of years prior. In the meantime, in other cosmic stories, stars generally follow a comparable musicality, moving from the center to the external edges at equivalent speeds. It's an inestimable movement, arranged by the gravitational draw of dim matter. But hang on, the smooth way seems to be the renegade artist in this astronomical ball. No other system has shown this specific log jam, called attention to by France Sledge from the Paris Observatory. This astronomical disclosure isn't just stirring up our heavenly dance floor, it's shaking a big infinite guideline. Cosmology generally says no spot in the universe is more extraordinary than another. Anyway, the smooth way, with its heavenly log jam, may be wearing the vast crown now. Early infinite math proposed our smooth way was a heavyweight, bragging a mass of around 200 billion suns. However, here's the bend, later recalculations put it at a critical 200 billion solar masses. Stargazers are quite sure of their apparent material estimations around 60 billion solar masses. Doing the math, if the two figures hold water, it paints an enormous picture where the dark matter to normal matter proportion is simply 2.3 to 1. That is definitely not quite the grandiose norm found in cosmic systems of comparable height. Anyway, a few scientists think there may be something else to this heavenly log jam story. It's like reading a book and sensing there's an unwritten section ready to be found. The smooth way may be holding more enormous secrets than we've uncovered up until this point. They've been looking into the inestimable obscure with the Gaia satellite, our space Sherlock Holmes, offering high-accuracy insights about stars up to a specific infinite distance. However, there's a twist. Past Gaia's enormous reach, there's an inestimable magnifying glass wilderness ready to be explored. Researchers believe the heavenly show could go off in an unexpected direction. Astrophysicist Lena N.B. from MIT, one of the inestimable investigators, suggests that stars further away, past Gaia's enormous handle, may be arranging their heavenly speed show. It's like an intergalactic difficult exercise. Assuming that a few stars are easing down, others may be firing up in the grandiose race. Lena N.B. suspects that the inestimable show could have more shocks up its heavenly sleeve to add. Vast flavor to the blend, there's the perplexing enormous melanic cloud, a cosmic sidekick circling the smooth strategy for getting around 160,000 light-years away. This astronomical companion is acting similarly as anticipated, moving to the tunes of standard dim matter models at a stunning pace of north of 650,000 miles per hour. It resembles a solid grandiose artist following the all-universal advances. Then there are heavenly REM, the divine reverberations of more modest cosmic systems, and that star clusters got altogether too near our smooth way and wound up destroyed by its gravitational ability. These heavenly streams paint an astronomical picture in accordance with the strong approximations, adding one more layer to the infinite secret. Whether or not mankind's written history is a simple blip of 10 or 5 seconds in the great plan of the universe, one thing is clear: the universe is a gold mine of old marvels and perpetual motivation. Shift our look to our grandiose terrace, the smooth way, there's a captivating vast tango at play. Later estimations hint that stars on the edges of our system are swaggering their stuff in sluggish movement contrasted with their partners in other universes. What's the enormous scoop? Well, there are several hypotheses, and one murmurs that our smooth way may be coming up short on an imperceptible, inestimable fixing called dull matter. The slippery substance impacts the gravitational dance of heavenly articles. There's an infinite riddle involving dull matter, the baffling substance we can't see, yet that appears to play a gravitational back and forth in the universe. One possibility shaking our inestimable comprehension is that perhaps we've been seeing dim matter in some unacceptable way. Our infinite compass may point off course. Here's where the European Space Agency's Gaia satellite ventures into the enormous spotlight. It's like our enormous analyst giving complex insights regarding the dance of almost 2 billion stars in our smooth manner. Consider it a cosmic movement example. The satellite's exact estimations have driven space experts to re-examine their vast movement notes. Stars at the external edges of our smooth way appear to be going slowly, testing our old suppositions about their speeds. Now, how do a star's speeds spill the infinite beans about a world's weight? It resembles checking the size of a group by how quick individuals are moving. Cosmologists, outfitted with Gaia's information, assess the joined load of our cosmic system's gas, dust, stars, and that tricky dim matter to be around 200 billion times our Sun. It seems like an infinite heavyweight, yet here is the unexpected development: it's around 5 times short of what we figured. One hypothesis to unwind this vast question suggests we could have been a piece graceless with our dim matter gauges. Perhaps quite possibly there's less dim matter out there than we already expected. It resembles figuring out there are fewer fixings in your vast soup than you naturally thought. But hang on, gauging a system resembles nailing jam to a wall, famously precarious. The Gaia information could have a couple of eccentricities, or our inestimable estimating tape could require some changes. Still, numerous examination groups have joined the divine examination, and they all appear to be murmuring a similar vast tune. If this grandiose disclosure holds, it's like opening another part in our vast material science coursebook, an upheaval that may make us reevaluate not simply our own smooth way but every elegant corner of the universe. As Stacy McCord, a cosmologist at Case Western Reserve College, puts it, this could be an infinite game-changer. Take an enormous excursion back to the 1970s when stargazer Vera Rubin and her infinite team set out on a heavenly adventure. Their central mission was concentrating on how stars behaved in other systems. Now, the inestimable playbook recommended that stars on the edges of a world ought to be inestimable dawdlers contrasted with the zippy stars close to the focus. Here's where the unexpected developments occurred. Rubin and her stargazing crew uncovered a grandiose shock. Stars at the most distant compasses of worlds were swaggering their stuff at almost the same speed as the ones closer to the vast dance floor. Imagine a cosmic disco where everybody, regardless of where they are, is moving to something similar beat. This inestimable disclosure alluded to the presence of something strange and covered up, dim matter, the imperceptible heavyweight champion that shapes these gigantic radiances around universes. Now focusing in on our grandiose lawn, the smooth way. Imagine trying to keep tabs on everything in your room while being inside it. Interesting, right? Stargazers faced a comparative vast test, assuming that the smooth way stars played by the same principles as those in other worlds. For example, our Sun, living around 26,000 light-years from the cosmic heart, wanders around at 800,000 kilometers per hour. The Gaia satellite, sent off in 2013, resembles our accuracy infinite ruler, measuring the positions and sweet moves of smooth way stars in 3 aspects. The information it's been sending back resembles a grandiose ensemble, step by step refining its accuracy over time. The hypothetical physicist Francesco Cini and his infinite investigators from the Enrico Fermi Study and Exploration Center in Italy noticed unpretentious traces of a heavenly stoppage a couple of years ago. With Gaia's most recent information drop in 2022, these clues became infinite firecrackers. The new data is 2 times as definite as the information in 2018. Cosmologists now employ gotten-to-the-next-level instruments to follow star parts with laser accuracy, arriving at vast distances that were once a bit fluffy in the divine theater of 2023. For independent exploration, papers have revealed a divine shock. Stars up to an incredible 100,000 light-years from the smooth way's heart appear to be going slowly. It's like the stars are stirring things up around the town. Clarion decay suggestive of the planetary val Johannes Kepler portrayed hundreds of years prior. In the meantime, in other cosmic stories, stars generally follow a comparative beat, moving from the middle to the external edges at practically identical rates. It's an inestimable movement organized by the gravitational draw of dark matter. Yet, hang on, the smooth way seems to be the revolutionary artist in this astronomical ball. No other universe has shown this specific lull, called attention to by France Mallet from the Paris Observatory. This enormous discovery isn't simply stirring up our heavenly dance floor, it's difficult. A simple vast standard cosmology generally says no spot in the universe is more exceptional than another. Anyway, the smooth way, with its heavenly stoppage, may be wearing the inestimable crown now. Prior, enormous math proposed our smooth way was a heavyweight, boasting a mass around 200 billion suns. However, here's the turn, later recalculations put it at a critical 200 billion solar masses. Cosmologists are quite sure about their visible material estimations, around 60 billion solar masses. Doing the math, if the two figures hold water, it paints an astronomical picture where the dark matter to ordinary matter proportion is simply 2.3 to 1. That is undeniably not quite the inestimable norm found in universes of comparable height. Anyway, a few scientists think there may be something else to this divine stoppage story. It resembles reading a book and sensing there's an unwritten part holding back to be discovered. The smooth way may be holding more astronomical secrets than we've revealed up to this point. They've been looking into the vast obscure with the Gaia satellite, our space Sherlock Holmes, offering high-accuracy insights about stars up to a specific vast distance. In any case, there's a curve past Gaia's vastness. There's a grandiose magnifying glass, boondocks, ready to be investigated, and researchers trust the heavenly show could veer off in an unexpected direction. Astrophysicist Lena N.B. from MIT, one of the grandiose young minds, suggests that stars further away past Gaia's grandiose handle may be organizing their heavenly speed show. It's like an intergalactic difficult exercise. If a few stars are easing down, others may be firing up in the infinite race. Lena suspects the infinite show could have more shocks up its divine sleeve to add vast flavor to the mix. There's the cryptic Large Magellanic Cloud, a cosmic friend circling the smooth way, around 160,000 light-years away. This enormous companion is acting comparably to expected, moving to the tunes of standard dark matter models at a stunning rate of more than 650,000 miles per hour. It's like a dependable vast artist following the general advances. Then, there are heavenly leftovers, the divine reverberations of more modest cosmic systems and star bunches that got all in all too near our smooth way and wound up destroyed by its gravitational ability. These heavenly streams paint a grandiose picture in line with the weighty approximation, adding one more layer to the enormous mystery. Anyway, in the grandiose analyst organization, incredulity is a guiding star. Cosmologist Robin Sanderson from the College of Pennsylvania makes virtual smooth ways on a PC, impersonating what Gaia could see. She focuses out that these inestimable plots depend on certain assumptions, like the state of the smooth way's dark matter commitment, which could influence the outcomes. She encourages caution in reaching strong determinations from the current infinite clues. The story doesn't end here. Our infinite voyagers are preparing for future missions. The Vera Rubin Observatory, with its full concentrations and eyes set on the stars, may unfurl additional heavenly privileges from the smooth way's external reaches. Gaia, the grandiose source, designs a stupendous uncover in late 2025, furnished with considerably more exact data in our enormous mission. Scientist Sledge is eager to look at different systems and check if their stars dial back like in our smooth way. It's like investigating space neighborhoods for a comparative heavenly show. This investigation is an ordinary piece of science, a piece like assembling a riddle where patience is key. The universe is like an immense library of secrets, from our close-by planetary group to the farthest infinite corners. Envision antiquated cosmologists scratching their heads over comets and stars. Those were the enormous riddles of the past. In spite of our super-advanced devices, like PCs and space observatories, we're as yet inestimable investigators, with about 95% of the universe enveloped by mystery. At the point when we look at the universe's edge, we start with the discernible universe. It's like looking through a window into the territory beyond. The discernible universe incorporates everything we can now distinguish, measure, and inspect with our telescopes and space missions. It is an assortment of stars, universes, and divine bodies that are apparent to us. the thing that matters is that the perceptible universe is only a piece of the entirety. Consider it to be a little piece of a monstrous inestimable pie that people can study and see. However, the general size and structure of the universe remain a mystery.